We have the next speaker also talk about the same. We have AI in manufacturing, transforming the way we make things. The speaker is a seasoned software engineer with more than 25 years of experience. He currently leads the Eaton, he's currently the chief architect at Eaton India Center at Pune, leading initiatives towards digitalization. Can I please invite on stage Mr. Apurva Sharan?
Thank you. So we are here to talk about AI in manufacturing. I think the last couple of sessions that I have heard have been all about Gen AI and how we are applying AI in various different fields. What has happened in the context of industries is that there has been a lot of, you can move on to the next slide. Yeah. What has been happening is that there are two things that have converged actually. As far as industries are concerned, manufacturing is concerned. There are two things that have been converging over time. AI by itself is nothing new. It has been there since 1950s in theory. And even from the early days when it was conceptualized, there was a lot of math, deep math in it, right? There's probability, there is statistics that is all going there. And the incarnation that has come now, which is finally becoming more and more useful, is mainly driven from convergence of something else as well that has been happening in the industry over time, and that is computing, right? So as we have progressed from 1970s to 80s to 90s to today, computing infrastructure has exploded exponentially. Moore's law has helped drive a lot of data generation, and that has helped in terms of making AI really, really useful. We have talked about Gen AI, but there's a lot of other things that have gone before that in terms of statistical machine learning, in terms of you just generating insights from data. So move on to the next. Yeah. So what we have actually been able to achieve through all this explosion of data, and by using the foundational layers of artificial intelligence, is we have actually tried to train the machine, train the computer to find patterns in the data. And if we look at it from the industrial side, from the manufacturing side, Industry 3.0 specifically, which is basically your automation and computerization of industries, that has helped a lot in generating all this data, right? So industries, Industry 4.0, which is the term that is being talked about now, is basically ripe for disruption. It is ripe to, in a position where this convergence can really be used and derive various improvements. It's a step function improvement. I would actually, in my own analysis, I think this is equivalent to the transformation that we are seeing today is equivalent to Industry 1.0. We have been doing things in a way which is using, okay. Okay, yeah, so basically we have all of this data which is coming from all these changes in the computing infrastructure, and we have all this math that has also been growing. What has happened in the last, since 2010s, I would say 2010 onwards, we have seen a huge improvement in our own ability to interpret that data as well, right? There is a step function improvement in computer vision. For example, till when I was in college, we were talking about computer vision using Sobel operator or various other mathematical matrix operations that we used to do. With AI, what we have been able to do is we have been able to give that task to the machine that, yeah, here is the high level structure of what we see or what we want to see in the data. Here is how we interpret as humans what we want to derive as insights from that data. Machine, can you actually pick that up from where we are today, and can you learn on your own? So that's basically what this transformation has enabled, the huge power of computing that has explored, that has enabled. So we're basically going from patterns to decisions. That's what I would really want to highlight here. And then this actually, when applied to industry, there are various areas which are basically going to benefit from all this transformation. Computer vision, as I mentioned earlier, is a if you look at an assembly line or if you look at a product that is created, you want to do a quality check. Today, basically, people will pick up that product, they will maybe inspect it visually. That task can actually be done by a machine. We don't really need, as in people don't really need to spend their time turning around the object and basically look at it from that perspective, right? The other side is, one is computer vision, that is from the outside. On the inside, you can actually embed sensors, right? So you have, whether inside the device or whether in the manufacturing process, you can generate all of that data. And in the past, people would actually look at those aspects and they would generate what is the quality of the product that we are really going to see when the product is created. We can give the task to a computer, to a machine, to process all of that. So this is one of the aspects. The other aspect is preventive maintenance. With all these sensors around, which are inside the device, outside the device, on the factory floor, you have humidity sensors, you have temperature sensors, you have even if you talk about Eaton, my company, we analyze data which are at a very high rate. We sample the current data, we sample the voltage data, and from that, we are able to really figure out how the product is going to behave today, tomorrow, 6 months down the line, 2 months down the 2 years down the line, and we are able to make a judgment on when we need to really do any preventive maintenance activity, right? So that's another key thing that is happening in the context of AI in manufacturing. Actually, there are some deployments also done within Eaton even today, where we are able to provide predictions, and those predictions have been even validated, right? If you give that same data to a person and ask them to really analyze that data, they are coming with similar results to what a machine is able to give you, right? And all of this, as we are going in the age of computing, growing further and further with Gen AI and various other things coming into picture, the scope of what we could do with machines far outstrips the human capability that we have on the floor. So basically making sure that the machines are able to really help humans, as mentioned in the previous talk, human in loop is definitely essential in that context. But the idea is that the AI or rather machines and humans, basically we need to work together and make sure that we are able to provide the best experience to our users and basically people who are using it, people who are manufacturing it. The other aspect which is very important from a AI machine learning perspective is ensuring safety, not just within the industry, but even outside as well, right? So specifically talking about industry now for a minute, if there is a situation that is happening in the factory, if workers are not really wearing safety gear, that is something that can be very easily evaluated by a machine at scale. There are already models that are deployed on factory floors where people are told that, yeah, you are not wearing the helmet if you should be wearing that. So that is definitely there. On the other side, of course, all of you would have heard stories of the surveillance state that is there in some countries where people are really monitored. But of course, I'm not going there, but there is a positive side to that as well, right? That we could actually help, even at a mass scale, we could help ensure that situation doesn't really go out of control. And that can be only enabled by a machine. Basically, people analyzing, if you look at a dashboard with multiple CCTV cameras and all that, it's physically not possible for really people to monitor the scale at which things are really changing. So the idea is that using AI, we should be able to leverage the machine capabilities to monitor and help address all of these concerns that we have. Finally, I think we have touched upon a few broad areas. Now, just a couple of things, a couple more things where industries are going to really change. One is demand forecasting for an efficient supply chain. AI engines can much more efficiently predict spikes in requirement depending on the geopolitical situations. Even if you put that in the machine, we should be able to predict that. How the parts that you have, the usage of components within the on the assembly floor in the manufacturing process can be very easily analyzed by these machines, and we should be able to leverage that as well. On the other side, of course, I mentioned monitoring and control, but not just from safety perspective. There are various other aspects in terms of, yeah, fine, a machine can decide that, yeah, there is something that is going wrong in a particular area, or something that is going out of control. Then a machine can actually help generate alerts, generate alarms, so that humans in loop, as mentioned earlier, can come and help control the situation there. I think these are a few areas that are going to get disrupted. Some of them are already in the process. Some more will take some more time. And this is still, in my view, we are just touching the surface of what is really possible today. As we progress in time, I'm sure there will be more and more areas. And even today, I think I may have missed some broad areas. But the idea is that the machines are there to help us. We need to, finally, we are the ones who are in the driver's seat. We need to make sure that we are using the machine to solve the problems that really need a step function improvement. And in that sense, I actually equate this to Industry 1.0 kind of a transformation that we are actually going through. When in the context of Industry 1.0, manual labor was replaced by some sort of assembly line and with steam power and various other things, right? So that kind of disruption that happened way back in 1950s, I think, if I remember right, is what we are actually seeing today and will continue to see in the next few years to come. With that, I think that's all that I have. I think I'm finishing well in time. If there are any questions, we can discuss.
Do you need a mic? That would be better. Check.
Yeah. So in terms of challenges, I think the first thing that comes to mind is finally it's humans who are deciding what needs to be done, right? And where the most effective use of these tools and technologies are going to be there. And in that, then we need clean data, right? If you really talk about AI, having clean available data in large volumes is what is really a challenge, which is actually helping, or rather hindering progress in some way. But I think there is enough work that is being done to make sure that we understand the domain. First thing is that there is a legacy which is there from an industry perspective, that people know how industries work, what is the most useful way to really interpret the data. We need to transfer that knowledge. And one of the things that we do is basically for many of these the problems that I mentioned here, there is physics involved, right? When you're talking about producing items, there is a real hardcore physics and chemistry that is there. We need to encode that information in terms of explainable AI, or something someone else mentioned here. We need to really look at all the rules and that are there, basic science per se, foundational science, as well as computer science, right? Plus all of the data that we have. So that's a huge amount of work that needs to be done. So I would just address that it's a challenge of time is probably where I would really go.
Thank you.
Any other questions?
Thanks, Apurva. Can we please have the memento back for Apurva, please?